Converting between systems. You can use a proportion to convert between measurement systems because it allows you to easily determine equivalent ratios. We have this table of customary and metric conversions that we are going to be using on every problem so that we know what numbers we need to use when we set up our ratios and proportions. Let's go ahead and try this first one. It says convert 17.22 inches to centimeters, round to the nearest hundredth. So I'm going to look in the table and I'm going to find where it shows me how many centimeters are in an inch, and that's up here with length. For every 1 inch, there are 2.54 centimeters. So when we're converting inches to centimeters, I'm going to do inches over centimeters, and then I'm going to use the numbers from the table. 1 inch over 2.54 centimeters. And then I'm going to set that equal to 17.22 inches. And then it's over centimeters still, but we don't know how many centimeters that is. So I'm going to write X centimeters. So now we have our proportion, and we just need to solve. Well, I can see pretty easily that if I did 1 times, that you can't see that at all, times 17.22, then I would get 17.22. Now, because I did that to the numerator, I have to do that to the denominator. So 2.54 times 17.22 will equal X. When I multiply that out, I get 43.7388. And that would be my answer, except the question says to round to the nearest hundredth, which is here. So I need to look at the number in the thousands place, the 8, to tell me what we're going to do with the hundredths place. And this tells me, in this case, we're going to round up. So 43.7388, we're going to round to 43.74, or 43 74 hundredths. So our answer is going to be 43 74 hundredths, and then we can't forget our label. We were converting to centimeters, so we're going to put centimeters. Convert 5 kilometers to miles and round to the nearest hundredth. So again, I'm going to go ahead and just show how we're going to set up our ratio. We're doing kilometers over miles, and I'm going to look in my table and I'm going to find where kilometers and miles are listed, and I found it right there. So 1 mile, for every 1 mile there is 1.61 kilometers. So I'm going to go ahead and write that first. 1.61 kilometers for every 1 mile equals, and then I have 5 kilometers and an unknown number of miles. So I'm going to put X miles. So with a proportion, we know that they are 2 equivalent ratios written as fractions, and so I should be able to multiply or divide 1.61 by something to make it equal 5. I can't think of any whole number that I can multiply or divide by to make 1.61 equal 5, so we're going to have to do 5 divided by 1.61 to see what I can multiply 1.61 by to equal 5. When I divide this out, I get 3.105. Now, the problem says to round to the nearest hundredth, so let's go ahead and do that. If I round this to the nearest hundredth, we're going to get 3.11, or 3 11 hundredths. So this means if I multiply 161 times 3 11 hundredths, I should get 500. And we were trying to see how many times 1.61 went into 5. Remember, we had to move the decimal, so that's why I said 161 and 500. Same principle applies. If I multiply 1.61 times 3.11, I will get 5. So because I did that on the numerator, I have to do the same thing on the denominator. 1 times 3.11 will equal X. Well, 1 times 3.11 is 3.11. So X is going to equal 3.11, or 3 11 hundredths, and then we are finding miles, so I'm going to put miles. Convert 8.5 cups to milliliters, round to the nearest hundredth. So we're going to go ahead and show how we're going to set up our ratios. We're doing cups to milliliters. So I'm writing cups over milliliters, and then I'm going to look in the table. This is capacity or volume, and so I want to find where cups and milliliters are listed side by side, which is right here. For every 1 cup, there are roughly 236 and 59 hundredths milliliters. So that's the ratio I'm going to write first. 1 cup over 236.59 milliliters. And because it's a proportion, I'm going to set it equal to another ratio. 1 cup over 236 and 59 hundredths equals 8.5 cups over, we don't know how many milliliters, so we'll put X milliliters. And I can see pretty clearly right away that if I did 1 times 8.5, I would get 8.5. So I can make 1 equal 8.5. Now, because I did that to the numerator, we must do the same thing to the denominator. So we have to do 236.59 times 8.5. Why don't you go ahead, set that up, and solve it on your own, and then press play to check when you are confident in your answer. So I got 2,011 and 15 thousandths, but we're told to round to the nearest hundredth. So if we do that, we're going to look at the thousandths place to help us see what to do with the number in the hundredths place. And in this case, we will round up. So it will be 2,011 and 2 hundredths, and then of course we need to make sure we label milliliters. Convert 3.4 quarts to milliliters, round to the nearest hundredth. So again, we're going to look in the table and find where it tells us how many milliliters are in 1 quart, and that's right there. So we are going to do quarts over milliliters, and we'll do 1 quart over 946.35 milliliters equals 3.4 quarts over, I don't know how many milliliters, so we put an X. Now, you guys should be able to see what we can do to one ratio to make it equal the numbers in the other ratio. So I'm actually going to ask you to finish this problem on your own, and we will check this one in class tomorrow. When you're done solving this one, press play to start the next problem. An Olympic-sized swimming pool is 50 meters long. About how many feet long is the pool? We need to round to the nearest hundredth. So when we're reading this word problem, we have to figure out what we are converting to what. And here we are converting meters to feet. So I'm going to go ahead and write meters over feet, so I know that's how I need to set up my ratios in my proportion. Let's look in the table. I see that for every foot there are 30 hundredths of a meter, or there is 30 hundredths of a meter. So I want you guys to go ahead and do this problem on your own. Remember, you're going to use the numbers from the table for your first ratio, and then the numbers from the problem for your second ratio, and I want you to solve and see how you do on this one. We will check this in class with our groups. Good luck. See you soon.